I would like to solve the hard problem of consciousness. So let me start with a mathematical theory of consciousness on its own terms. So I'm not trying to ask what properties of neurons could cause consciousness. I'm not interested. I'm asking myself the scientific question. If I knew nothing about the physical world, I just wanted a theory of consciousness, what would be the mathematical structure I would write down in consciousness? And what dynamics would I write down?
Don, the last time we spoke, 7, 8 years ago, I think now, um, you were proposing the concept that consciousness is fundamental, and that the physical world, which we think is fundamental, is somehow derived from it. Very controversial position, obviously, but since then, you have developed this more as a mathematical way of thinking. In terms of describing what the conscious realm would be like from a mathematical description of the fact of consciousness. And you propose, I think, correct me if I'm wrong, that there is a realm, a fundamental realm of conscious agents, which you call conscious realism. How can that be realism?
Right. So So there's two steps, and they really are separate claims. One could buy one claim and not the other. Okay, so they are independent claims. So the first claim is a technical one that we've just talked about. My claim is natural selection does not favor true perceptions.
Okay,
Clean.
now let's say I grant you that, which of course I haven't, but let's say I do grant you that fully. Take me to the logical process to the second.
So the next step then is, if my senses aren't showing me the structure of reality, then my perceptual structure of space in 3D, of objects with colors and shapes and motions, of neurons and brains, those are video game symbols, but they're not the truth.
Mm-hmm.
So this now opens up the question, what is the nature of objective reality? Now, one story that you could give in spite of all this is to say magic. It's exactly what we see. But that's magic, right? I mean, I've just taken out any reason on evolutionary grounds for us to believe in that magic. But of course, you could certainly go there and just say it's magic. I mean, we see our senses show us a world in 3D, and that's because there is one, and it's magic without evolution. Evolution didn't do it. But I was motivated to propose a different theory, and now this is an ultimately different proposal, right? So now the evolutionary theory is one thing, we're done with that. Now the question is, what is the nature of objective reality? And my motivation was this hard problem of consciousness, right? So there's been this really tough problem for centuries. Actually, Leibniz understood this hard problem of consciousness very, very well back in 1700. But it's been around for centuries. We have, on the one hand, our conscious experiences, like I see a green light and I experience the green. And we have also brain activity. Right? I have area V4, say in the left hemisphere of my brain, and it turns out that there's a correlation between activity in V4 and my experience of color. And if I inhibit V4 with transcranial magnetic stimulation, I lose my color experience in the right visual world. So there's this clean correlation. I can intervene with the brain activity and alter the color experiences. And there's so many of these correlations between conscious perceptual experiences of various kinds and brain activity on the other hand. And the question is, of course, to have a scientific theory which explains the correlations. The correlations, of course, are not a theory. Right, to say that area V4, if I stimulate it, I get color experiences, that's no theory. That's just a piece of data that we want to explain. And even if I could even find out that I only experience this particular shade of green, right, green 52, if and only if this particular neuron in V4, this neuron 3 billion, 22 million, and so forth, that neuron firing at 30 hertz is my experience of the color green. Even if it was that simple, we would still have to explain that. What's the miracle such that that neuron firing at that rate leads to the conscious experience of green. Of course, it's not that simple, but I'm just making it that simple just to see how stark the problem is.
And as I look at the hard problem of consciousness and have, as you know, we've explored every possible theory, they all come down to, in some sense, this may be controversial, a kind of identity theory. Whatever you think it may be, that is it. And in every case, there's the hard problem is not changed, whether it's a firing of a neuron, whether it's the quantum reverberations in the within the cell, whether it's some structural dimensions of space-time, whatever it is that you think it is, there's this identity that my perception of green, or looking at you now, is that thing.
Exactly.
And that's always problematic.
It's always problematic. They often, I agree, make an identity, or they have some kind of causal idea that maybe somehow the neural activity, the functional aspects of the neural activity somehow causes or gives rise to the conscious experience, or they'll try to identify it. They'll say it's exactly the same thing as. But as I was looking at that and realizing how hard this is, and by the way, as you well know, the people who are doing this are extremely bright. These are some of the brightest minds. They're my good friends and colleagues. They're working on a really hard problem. So it's not for lack of brilliant minds. And so we've been really stymied for centuries, and especially for the last 3 or 4 decades, working really hard on this. And I began to think, well, maybe this idea that I've got from evolution could fit in here. Maybe the problem that we have is we've assumed that there are neurons because we see neurons. We assume that neurons cause consciousness or are identified with consciousness because why? Because we see them with our sensory systems. Well, I just have this theorem from evolution that says there's no reason to believe that the structure in our perceptions tells us anything about the structure in objective reality. In other words, what we think of as causality in space and time, like neural activity causes my arm to move. Neural activity causes me to have the experience with color green. That kind of notion of cause is a fiction. Strictly speaking, nothing in space-time has any causal abilities. It's to give you an idea of what I'm saying here. In the game Grand Theft Auto, right? I've got a steering wheel, and I can intervene with that steering wheel. I can say, look, I will turn the steering wheel to the left, and notice as a result of that, I cause my car to turn left. If I turn my steering wheel to the right, I cause my car to turn right. Well, that's perfectly fine if you're playing the game. That it's deeply false, right? The steering wheel does nothing. The steering wheel is just a useful fiction, and the cause that the steering wheel causes to turn the car left and right is useful fiction in the game. And if you're playing the game, just believe it. But if you're a game designer, you would be a fool to think that the steering wheel does anything. You have this much deeper understanding of the software and the hardware of the computer, how you're putting pixels on the screen that the person just sees as a steering wheel, but that steering wheel does nothing.
Right.
And that's what evolution has given us. It's given us pixels that we interpret as neurons. And for everyday neuroscience, it's perfectly fine, and it's very helpful to talk about neurons as having causal powers. It's only when you really have to understand the deep workings of the system, like with the hard problem of consciousness, that fiction now comes back to bite you. So for everyday neuroscience, yes, neurons, you can think of them as having causal powers, causing our experiences and our behavior. But just like for a system designer for a computer game, you have to lose the fiction to write the game and understand how the game really works. What I'm proposing is to understand the hard problem of consciousness. Now we have to give up the fiction of space-time and causality within space-time. That fiction, which is perfectly fine for most everyday science, is what's biting us here in solving the hard problem of consciousness. We have to have a deeper theory, which we explain both consciousness and how then our experience of space-time emerges. Now this finally gets to the question you asked, which was, I was saying that evolution by natural selection in our current physical theories like quantum theory and general relativity would be theories on a deeper theory of consciousness. So the reason I'm going there is the following idea. I can't start with space, time, and matter as the fundamental reality, right? They're just the game. Evolution has given us the game. Those are just the symbols of the game. So if I want to understand how neural activity is related to conscious experiences, I'm proposing, and this is now the leap. This is independent of my work on evolution. So you can buy the work on evolution and throw what I'm about to say out the window.
Or the reverse.
Or vice versa. You can throw everything out the window, but you can throw them out for independent reasons. But what I'm saying is, if you want, I would like to solve the hard problem of consciousness. So let me start with a mathematical theory of consciousness on its own terms. So I'm not trying to ask what properties of neurons could cause consciousness. I'm not interested. I'm asking myself the scientific question. If I knew nothing about the physical world, I just wanted a theory of consciousness, what would be the mathematical structure I would write down in consciousness? And what dynamics would I write down? And now, for it to be science, whatever I come up with in my theory of consciousness has to lead to testable predictions. Well, the only testable predictions we can have are back in our game, right? Back in space-time. So that's why I'm saying whatever theory of consciousness I come up with, when I have to show you how that projects back into what I call our space-time user interface. And when I project the theory of consciousness and its dynamics, I better get back something that looks like evolution by natural selection, general relativity, quantum field theory, or even deeper theories that show that there are special cases. If I can't do that, then my theory of consciousness is wrong.
Yeah, certainly that makes sense. So let me ask you to describe your theory of consciousness in terms of a mathematical description of the nature of consciousness. And you look to some kind of realm of conscious agents.
Right. Right. So this now leads to a really interesting big question about how science works and what we do as scientists when we're trying to boot up a new theory. And what every scientific theory has assumptions, right? You can't explain everything. And strictly speaking, there is no theory of everything, right? Every theory says, if you would please grant me such and such assumptions, then I can explain everything else. So grant me that there is space-time and quantum fields. Then I can explain chemistry and biology and all this other stuff. You can't explain everything, but you can have certain assumptions. And so in the case of consciousness, if you think about all the different aspects of consciousness that you might want in your theory, there's headaches and the smell of garlic and the taste of chocolate and there's all these emotions. There's somehow the notion that our experiences inform our actions. Maybe they inform them maybe one have a notion of free will or some kind of notion about how our behavior is influenced by our experiences. There's the notion of self, and self-awareness and awareness of others. So, there's countless things that you might want. There's memory, right? I have experience of memories, learning, problem solving, intelligence. There's tons of things that you would want your theory of consciousness to deal with. Now, if I just assume all those in my theory, well, that's not very, very good, right? I mean, if I assume then everything's a miracle, everything's just an assumption. So what I want to do is to say, of all the features of consciousness, what is the minimal set, the absolute bare minimal set of assumptions that I can make, that I can then boot up a theory of consciousness that will give me everything else. I'll have to work for it, right? I'll have to work hard to get everything else because I didn't assume it. And so what I'm proposing, and other people can have different starting points. My proposal is I need two things. Conscious experiences, like the taste of garlic, the smell of a rose, a headache, those kinds of raw experiences as experiences. So I need to be able to say that they exist. So that's one of my assumptions. That's, so to speak, a miracle for me.
Mm-hmm.
And the other one is that those experiences non-trivially influence some kind of action. Now you can interpret that action in various ways. I tend to interpret it as free will, but mathematically, all I need is that there's a probabilistic relationship. The experiences probabilistically affect the actions that occur in response. Okay, that's my assumption. And so then what I write down is what I call, this is very much in the spirit of like what Alan Turing did when he came up with the Turing machine, right? So What Turing was trying to do was to say, I would like a theory of computation, a minimal theory of computation. And computation is really a wide-ranging thing. I can compute the digits of pi. I can do the traveling salesman problem. There's lots of things that are involved in computation. What Turing boiled it down to was this trivial thing. I have a tape with some ones and zeros on it. I've got a set of transition rules and a finite set of symbols, a start state and halt state. And the claim is, with that trivial set of assumptions, I can compute anything that's computable. That was the so he didn't assume that he knew how to compute the digits of pi. He made that something you'd have to do. You'd have to build a Turing machine that computes the digits of pi, and it's not easy to do, and so forth. So that's what I'm doing here. I'm saying, let me give a minimal structure, and it's about as complicated as a Turing machine, right? The structure that I'm writing down. It's a different structure than a Turing, but it's not the same thing as a Turing machine, but it's a minimal structure. It has a set of conscious experiences and a set of transition probabilities that those experiences will affect then the experiences of other experiencers, right? Other systems that have
Do
experiences.
you need multiple instances of this when you have your conscious events, and then you have the fact that they can cause something, but
Right.
don't you also have to assume that there are multiple instances of these activities?
That's right. So
Third assumption.
just like Turing has, there are, in fact, Turing proved there's a countable infinity of Turing machines.
Yeah.
So I have this structure that I call a conscious agent, and there's going to be a large set of conscious agents, right? And so the idea will be that each conscious agent has its own set of experiences and then probabilistically affects the experiences of other agents. And so I'm going to get, this is, if you think about it, it's going to be a network dynamics. This is like a vast social network that comes out of this. So all the new mathematics that we're doing to understand Twitter and all these social networks is the mathematics that we need to use to study the dynamical systems of conscious agents that I and my team are working on. So it's this vast social network, and it's dynamics on graphs is the mathematics.
Well, I love the new approach to consciousness, right or wrong. You're busting barriers. You're looking beyond the traditional ways, and I really applaud that. And I want to conclude by looking at two results. Given the fact that what you say is correct, once again, I like to say everything you say is now correct. You have a different approach to the question we asked today, whether AI, artificial intelligence, can be conscious. Now, most materialists, a lot of the Silicon Valley group, many neuroscientists have no doubt that given the amount of time and complexity, AI must become conscious because there's no ghost in the neurons, as they might say. And so it has to be the case. It's not even worth a discussion. I think it is worth a discussion. There are other issues. But you say that AI can become conscious, but for a radically different reason than what the hardcore materialist would say.
That's right. It's a completely different framework, right? So the standard physicalist framework is saying that somehow if a physical system is complicated enough, then it will give rise to consciousness or be identical to consciousness, right? So it's a matter of getting the right kind of sophistication, the right kind of complication in it. And I'm saying the very notion that space-time is fundamental and that physical objects have causal powers is fundamentally wrong. The whole framework is gone. As some physicists put it, space-time is doomed. There is no such thing as space-time in the fundamental structure of reality.
Yeah, but I think they're saying that in a different sense. They don't say that in support of consciousness being fundamental. They say that in support of some deeper theory, whether it's string theory or something else. So to be fair.
Right. So I'm agreeing with them that space-time itself is not fundamental and that causality in space-time is not fundamental. So what is space-time then? It's just our user interface, right? And so the idea is, think about it this way. If you have overwhelming social media data like Twitter, there's literally tens of millions of users, billions of tweets. There's no way that any Twitter user could read all the tweets or interact with all the users. So what do you do if you have overwhelming social data and you just want to understand what's going on, a big picture, and occasionally contact a real Twitter user, right? You can contact a few of them. So what do will you build a visualization tool, maybe a virtual reality visualization tool? So you have pretty icons and things moving around to show you what's trending in New York versus London. Zoom out to all of the United States, zoom over to all of Europe. That's what you're going to have. You would want from a good visualization tool. You can zoom out and get big trends, but you could also zoom in and talk to John Smith in Iowa, and talk to him particularly on Twitter. So that's what you would want with the big tool. So that's what I claim space-time and what we call the physical world is. It's just our headset. It's a visualization tool. So in this picture, the reality is this vast social network of conscious agents. We've been mistaken. We thought space-time is the final reality. It's just our headset. And what science has been doing all along is just studying our headset. Now, our headset does give us certain icons, which are portals, direct portals to other consciousnesses. I'm talking to you, and I have an icon of a face and glasses and a smile and so forth. That's just my icon. It's not you. If I closed my eyes and my icon disappeared, your consciousness would still be there. So my icon is just my icon. But the key point is I have an interface that gives me a portal into your consciousness. Not exhaustive. You can fool me. I could fool you. I mean, I could pretend that I'm, feeling fine if I have a headache. And there's all sorts of ways I can fool you. But it's a genuine portal. So that's the point. We have an interface. We know that our interface does give us genuine portals into certain consciousnesses. So now the question is, as scientists, if we really get a mathematical model of this dynamics on graphics of conscious agents, we really understand it. We understand how our space-time interface arises from it with mathematical precision. So we're like in the position of the game engineers. We know the supercomputer, we know the software in the virtual reality headset. Once you know that, now you can play, right? You can actually rejig the software and change the interface. So here's the question, the AI question gets turned around. Is it possible for us to rejig our interface using what may look like technologies like silicon and voltages and so forth to open up new portals into this pre-existing realm of conscious agents? So I'm not trying to create new consciousness. I'm saying there are all these conscious agents out there. Can I open up a new portal into that realm? And for what it's worth, I think yes. I think once we understand, we can do it.
When you say there's this realm of conscious agents, does that mean there are individual, independent substances of some kind out there? Is there a finite amount? Are they being created? If an AI would become conscious in this way, which is a very innovative idea, does that mean it has to take over one of the pre-existing ones, and that means there's one less for everyone else, or are these constantly being created like sort of a steady state universe of conscious agents?
Well, it's more like, right. So great question. So first, yes, there are many conscious agents, an unbounded number, and the mathematics indicates that when two agents interact, they are a new agent. So this is a scale-free model of agency. In some sense, you could think that there's one big agent, but I can also anatomize it, fortunately for science, to countless other agents and look at their dynamics. And in some sense, doing that would give me a bigger picture for the other agents.
And these can combine in any kind of permutation and combination.
Apparently, and we're working on to see what constraints, if any, there are on that. But one hypothesis I'm playing with is that if consciousness is all there is, suppose consciousness is the story, right? That's what it is. That's this ontology. It's all about consciousness.
Right.
Then Gödel's theorem, which is interesting, Gödel's theorem, his incompleteness theorem, basically, bottom line tells us that there's no end to the exploration of mathematical structure. No matter how much you've explored, there's countless more structures to explore. Well, if consciousness is all there is, then that structure, the mathematical structure, is only about the possibilities of consciousness. So this leads to the idea that there's this infinite range of potential conscious experiences, what I call Gödel's candy store, of all these possible kinds of consciousness. And that's what consciousness is up to. It's a big search through this candy store, exploring all the possibilities of consciousness that will in principle never end. So that's why I don't even know if it's an infinite number of conscious agents, but it's unbounded, just like Gödel says it's an unbounded set of structures that
Don, I wish our conversation would never end like the conscious agents, but I just have to ask you one final question that relates to how everything you've proposed could be a solution to Fermi's paradox, why we do not see alien intelligences in the vast universe. So tell me that, and then this conscious agent will try to absorb it all.
Right. So Fermi's paradox is, where are they? Right. I mean, that's a big universe, and if there's intelligence out there, we should have seen it by now. And we keep looking and we don't find any. And from this point of view, in which space-time isn't the fundamental reality, it's just our headset, and the reality is this infinite network of conscious agents. What we're doing is we have this headset on, we're looking inside of our headset and saying, I don't see them anywhere. Well, you're not looking in the right place, you're just looking in your headset. Right? Science, up until now, with all of its dramatic successes, has only studied our headset. We're just now, if this whole framework is right, we're just now in the position to start to look at objective reality beyond our headset. Well, I'm proposing that once we do that, we'll realize that they were out there in droves. We were just like ants that couldn't see the guy with the raid can coming at them. We just couldn't see. We weren't looking in the right place.
So Don, when we do this again, say 10,000 years from now, and deal with the same subject, what do you think our conversation will be like?
If this works out, one implication of this is that we will be able to understand how we create space and time as just a headset. It's just a virtual reality. It's not the truth. That means that we will be able to play with the parameters of space-time itself. So once we actually work out the mathematics of this network of conscious agents and how our particular headset is generated, we will be able to play with space-time. The technologies that are going to come out of this are unbelievable. So yeah, I can't wait to see what happens.
10,000 years from now, you have a date where you'll be able to say, "I told you so" to this skeptic.
That's right. And I'll say, well, I'll see you tomorrow on Alpha Centauri.
Thank you for watching. If you like this video, please like and comment below. You can support Closer to Truth by subscribing.